everyone. I'm Pavan. I'm a Cube Simplify ambassador, and I'm a developer advocate at a company called Robusta. Thank you for joining us here today. We'll be talking about service mesh. With us, we have three amazing people who are really good at what they do in the service mesh space. So we'll we'll learn a lot from them. We have Marino from Solo and Rohit from Solo, and we also have Catherine here. Um, I'll let you all introduce yourself, starting with you, Marino.
Hey everyone. Sorry for the hoarse voice here. I'm actually losing my voice from all the speaking that I've been doing here at reInvent. Oh my gosh. Anyways, I am a developer advocate at Solo, and I specialize in the world of application networking engineering. So, I'm pretty happy to talk to you all about Service Mesh. Do apologize for my voice. It's kind of hard for me to speak, but I will try my best.
Yep. Thank you for the intro. We're waiting for Catherine and Rohit. While you are here, people follow Cube Simplify. We also make videos on YouTube. Follow us there. We bring content related to Kubernetes and cloud native in general for everyone. While we are waiting for them, Marino, could you please introduce? Okay, we have Rohit here. Give me a second.
Yeah, I think Kat has to switch to a mobile device.
Hey, there it is.
Yep. Hi, Rohit.
Hey, Pavan, can I ask you to mute when we're speaking? Because we're getting a lot of feedback on this side.
Yep.
Hello everyone, how are you?
Hi, Rohit. Could you please introduce yourself?
Yeah, sure. Actually, I was just checking my mic, so it was I don't know like Twitter issues. So I'm Rohit Ghumare and I'm developer advocate at Solo.io. So Marino is another developer advocate. So yeah, we will be talking more about service mesh and kind of a thing. So we at Solo is our products are built on top of like service mesh, STO, Kubernetes, and Cilium, GraphQL. So we work on various technologies, and yeah. So I'm the guy who you have like if you're on Twitter, you have seen like I speak on DevOps, Cloud Native, and I build communities. I trying to nurture them. So yeah, to see it like interactive kind of a talk. So Twitter Spaces, I'm seeing forward to it. Excited. Yeah, thank you.
Yep. We're excited to have you here. Catherine, can you please introduce yourself?
Sure, gladly. So my name is Kat Morgan, commonly seen as user bin Kat on all of my handles everywhere. Recently was working with the developer advocacy team at Kong. Switched over to do some work at Microsoft on the software engineering side, but Mesh is still close to my heart. So excited to dive in with everyone and just see where the conversation goes.
Awesome. We'll start right away with the most important and most basic question, which is what is service mesh and why should anyone care about it? Uh, any of you can start.
Yeah, so I guess I can go forward with the same. So service mesh is something like it will like it will enable like development of your microservices, and you can add various type of add-ons to it. You can add various policies to it. So if you are in the Kubernetes and cloud native world, then you have like various things to work on through the microservices. So when the actual thing comes, like how to claim the policies and how to add the policies, then it comes the way of the service mesh. So yeah, I guess Marino can add the points to it. So thank you.
Yeah, thanks so much for that intro, Rohit. So there's a couple of challenges that we see in the world of like running microservices, right? I'll talk about three, and I'm like really struggling here. The first challenge is like, how do we connect to all of our microservices in our containers? If we did this with traditional networking, we would literally be sitting here for hours trying to get two containers to talk to each other. And then trying to do this 1,000 times over isn't going to scale very well if we're doing this by hand. So that's one problem. The second problem is when we are interacting with microservices, I may be interacting with one microservice, but then that microservice might be interacting with several others to give me a response. If I make a request using my client and I respect a response, somewhere along that request path, there are going to be multiple services that interact with each other. Now, when that occurs, maybe there's a service that breaks, and we need to have some level of observability to see what happened, why did it break, what went wrong, was there latency, was there something else that went on with the specific microservice in that request path. And the very last thing that we always have to consider is things around zero trust security. How do we make sure that we allow certain services to talk to other services and disallow other services from talking to other services, in addition to providing a layer of encryption when these services communicate to each other? And this is what a service mesh actually aims to solve. It layers in a set of capabilities into, let's say, a Kubernetes environment that allows you to do things like traffic management, to see what your microservices are doing and to secure them. But that's what we do here in the world of service mesh.
Okay, I'm going to dive in. All of the technical background that's been shared so far is really solid and obviously important to mesh. But what I really like to do is kind of relate it in familiar terms. And one of my favorite analogies for service mesh is something that presumably all of us have, and that's a cell phone. And it's fun to talk about it in terms of the history of the cell phone. So when phones originally happened, it was really cool. You could get information all around the world really fast, and the information was being sent to its destination instead of somebody physically carrying it with a letter or word of mouth or whatever. But the cell phone analogy is really special because presumably we usually carry our phones in our pocket. They're always with us. They're like the human sidecar. And that's a fun foundation for this because it's really how a service mesh works in a distributed system. So a distributed system, you have all of these different services that could be running anywhere at any time, and you get to address them based on the state of the mesh, which follows that all around. And that's how I like to open up the conversation.
Yeah, so another thing was like Docker and Kubernetes was like already doing various stuff around distributed services through like microservices, but it is like they were like means like execute somewhere like existing communication programs, and there was like if one service was taken down, then everything was shut down. So that time like service mesh was needed because there should be somewhere to do the service discovery, timeout, circuit breaking, and tracing and authentication. This type of things they should see. So that I guess it was introduced. And another thing was like some companies was built on only one language. So how to do communication between the both languages and different language dependencies. So in simple word, it is like to join the networking and business logic in the one system. So service connections. That time, I guess service mesh was introduced, and it is really nice technology. So let's deep dive into the same.
Cool. Those are some really great examples. Uh, Kat mentioned about sidecars. So can any of you please elaborate on what sidecars are and like simplify what it is? Sure. Go ahead, Martin.
So I hope you all know what a router is because that's effectively how I view a sidecar. So in the world of networking, traditional like layer 3 networking, we have these devices called routers. And what they do for us is when I want to communicate with someone else, but I don't know how to get to them, that router will basically tell me how to get to them. Now, in that world, there was only one device doing this. And the reality of something like this is that it wasn't very scalable, especially when we're handling large amounts of traffic and various different objects communicating with each other. So what we did in the world of cloud native is we basically took that router like functionality, cut it down to just the bare minimum, and we deployed it as something called a sidecar. So there's something in the world of Kubernetes called the sidecar pattern when you deploy pods, where you can actually deploy a secondary container to run alongside your main container. That secondary container inside of your pod shares the same networking namespace as that pod, so it's able to communicate with the same container in the same secondary container inside that main pod. But what it's also doing is for that main application container, for whenever it needs to communicate, it's going to use that sidecar, which happens to be a proxy. That proxy is going to receive inbound communications and it's going to send outbound communications to wherever it needs to go. But it doesn't know how to make those decisions. It actually makes those decisions based off of a control plane that's disaggregated or actually distributed from it and decoupled from this sidecar resource. It just receives instructions and then it knows what to do. Now, today in the world of service mesh, there are a few options out there for sidecars. One particular option is something called the Envoy proxy, which is a pretty versatile high performance router that does a lot of things both at layer 3 and 4, so at the IP layer, at the TCP IP layer, and even at layer 7, where we're doing a lot of HTTP processing. Now, the reason for this is because Envoy is able to now better understand things like HTTP requests, the response codes, etc. And what it aims to do is respond on behalf of that application container. So when you have multiple services talking to each other, it's not the services that talk directly to each other. They leverage the sidecar to have that communication. Now, the sidecar also does a number of other things too, but I'll stop speaking there because I know Kat has some thoughts to add there too.
Yeah, thanks, Marino. So the sidecar pattern has really taken off like wildfire in the service mesh world, and there's various competing implementations, but that's the foundation of the technology and how it's originally developed and commonly used right now. So the cell phone analogy, it's really fun because we hear all the time, like, people spend too much time on their phones. They're always on their phones, right? Well, in the land of service mesh and distributed systems, once we implement that mesh, the application is always on its phone or sidecar, if you will. And that is how it's one-stop shop, if you will, to speak with anything else. If it needs to find the address of something else or discover something by its DNS name inside the mesh or what have you, it goes to that sidecar, and that's all that the application has to know about. So that's all that the application developers need to know about.
Yeah, so that was like nice principle introduced by the Envoy, like during the announcements of the sidecars. So it was like the network should be transparent to the applications. So when network and your application problems do occur, it should be easy to determine the source of the problem. So we think like transferring like any packets or any intermediary functionalities we are adding to our traffic is done by the proxy of our service mesh. So that proxy in the any side plan, your sidecar plane or your data plane is known as your sidecar attached to your port or your proxy which is attached to it. So it was like if you want some understanding of the application level, like how it constructs and how the protocols work, like your HTTP or gRPC, and enhancing the your business logic for it. So then comes your sidecar proxy. So adding any resources or adding any capabilities to your own containers or pods or your microservices, that thing is known as the sidecar. So yeah, Marino, you can go ahead.
Yeah, so the only other thing I wanted to add is there are two additional things that the sidecar does. But before I get to that, if you were a developer today, right, and you always had to codify IP addresses or DNS names into every time you recompile your application, that's not going to be scalable, right? The other thing too is if you had to codify your, let's say, identity, right, your identity basically proving who you are or what this app is, you'll have to recompile your application every time that identity changes, which is not practical. The last thing too is you'll have to find a way to implement some sort of instrumentation in your code so that it can send log data, it can send tracing data over to some sort of system. But the problem is you have to keep modifying your code, which we don't want to do. We actually want to leave the code just to focus on what it's supposed to do and have these particular functions sit in the sidecar. So the other two things that the sidecar does is it actually provides the capability to do inline encryption between services that communicate with each other. What that means is when two services communicate, they're not communicating in plain text. There is an encryption there. There's actually TLS encryption there. But how that happens is these sidecars need to form a tunnel to each other using this concept called mutual TLS. So mutual TLS is the approach of both ends of that communication stream basically verifying each other that they're allowed to talk to each other. And once that's confirmed, then those two services can communicate. The other thing that the sidecar does is I just talked about it is instead of having to codify your or instrument your observability right into your code, you do this at the sidecar level. So whenever a sidecar is receiving communications from its main application container, it knows what this application container is trying to do. It knows who it's trying to communicate with. It knows how long it's taking to provide a response. And it could take all this data, aggregate it, and share it somewhere to like an external system that you can use to better understand how your applications are performing, if there's latency in how your applications reply, or even if, for example, you're trying to understand why an application might be returning, let's say, an HTTP 404 not found or something along those lines. But this sidecar that's deployed with this application container sitting in a pod gives us this information. And when you do this 1,000 times, we know what all these 1,000 pods are doing.
That's that's really great. Now I'm very clear about what sidecars is. Kat, do you want to go ahead?
Yeah. So
Sure.
recoding what the sidecar is in another real world analogy, we're probably used to the idea of couriers, mail carriers, DHL, UPS, what have you. If anyone's ordered from Amazon, they get notifications, hey, your package is here, right? And that translates to the packet carrier, service mesh network. Because that observability piece is really evident when you have real-time updates. Hey, your package is, just around the corner. It's 10 stops away from you or whatever, right? The utility from the operator side is that you have visibility into what is happening all across your network at any time. The nature of distributed systems is a two-sided coin. You have the benefit of fewer single points of failure, But now you have exponentially more points of failure to debug and observe and try to understand in your production. So that is one of those things, that logging piece, the observability, insight into what is actively happening across this now massively more complex system.
Cool. That's a very nice example. Now, I'm really clear about the sidecar analogy, but I'm curious if service mesh only exists in the Kubernetes world, because most of us know sidecars from being something that is inside a pod or in the Kubernetes world. Is service mesh only related to Kubernetes, or is there more to it? Sure, go ahead, Marin.
So I think service mesh is actually a higher level or higher layered construct because while it was originally made for microservices, it actually has evolved to accommodate different kinds and styles of workloads. So service meshes can interact with virtual machines even if you tune it correctly. So that way you can have, let's say, a virtual machine. And if you're not familiar with a virtual machine, it's just basically um, a logical unit of compute inside of a physical machine, except it has dedicated CPU memory and disk, and you can deploy an operating system to it, and then you can deploy your code on top of that. It's a little heavy, but guess what? A lot of people in this world today still run virtual machines. In fact, your Kubernetes cluster is on top of virtual machines most of the time. So you're not escaping that one unless you're doing bare metal at this point. That being said, right, a mesh is going to continue to evolve to accommodate things like, even let's say sorry. So you got virtual machines, you got microservices. What about like WASM? What about like, you know, basic eBPF based sandbox programs? Maybe we can't get there yet. There are so many different kinds of computes out there. What about functions for that matter, right? How do we provide these kinds of capabilities that a mesh gives you to these different styles of workloads? So I don't think we're entirely there yet, but I think because of the fact that service mesh seems to be the de facto layer for being able to achieve this style of communication, this style of interaction, then for these kinds of newer workloads that we're seeing, it might be the best fit. But that being said, I don't know. Like, maybe a year from now, someone else might come up with a brilliant technology that says, hey, service mesh is great, but we could do it better this way. So that being said, I can't really say for sure if service mesh is going to be able to accommodate all styles of workloads, you know, in the future, but I'd love to hear other thoughts on that.
Yeah, so Kubernetes has been really special in that it has been so wholly bought into by so much of the compute of Earth, really, that, and beyond, I guess, that it's forced us to be extremely efficient and inventive with building patterns that are effective at managing really big scale systems. And because of that, which is where the service mesh paradigm was really born, the service mesh has proven to be an incredibly powerful pattern. In my opinion, this is obviously hypothetical, but I believe that service mesh will outlive Kubernetes. So when we talk about whether or not service mesh is applicable to only Kubernetes or to compute beyond that, including everything from bare metal to possibly IPMI layer, systems, all the way up to what if we're doing those ML like AI API functions at some point. And coming from Kong, I really valued the way that they coded the Kuma service mesh. The Kuma mesh is a CNCF project, of course, but the way they coded it, the sidecar can be placed anywhere. It's happy in a container, it's happy on a virtual machine, it's happy on bare metal, and it's happy in a container runtime like ECS or what have you. So we're seeing experiments happening in the real world, even in productions, where the mesh is blending into other forms of compute. And the way that that has proven successful really suggests to me that the pattern itself, again, will outlive Kubernetes. Go ahead.
Yeah. I agree with Kat. So like it it is not about just Kubernetes because it is evolving really rapidly. And as we see, like there are new types of like service mesh advancements are getting releases, and it is not like we need only Kubernetes cluster to launch your service mesh or your work on your microservices. You can do it on like any kind of engines or any kind of your system. So it is not like you need only Kubernetes kind of thing. So as we see, like there are one I guess if you want to get a more clear picture on this, like there are various CNI stacks, networking stacks are released by various companies. So one of them, I guess, is from Marino, I guess. So like future of our service mesh is not just about Kubernetes, right? So as we see, like previously in the KubeCon, it was just about Kubernetes, but now they are talking about eBPF, they are talking about WASM. So it is just like how the cloud native world is revolving and new technologies are coming. So it evolves according to it. So hence, like our as we see, like Istio ecosystem. So Istio ecosystem was like currently they are working on the sidecar kind of a thing. So previously it was Envoy proxy, but now there is like sidecarless is introduced. So in future it can happen like you can directly integrate the eBPF, and you can advance everything through eBPF. So we will not require some logging problems also. So you can directly get the matrix in Go. So I think it's like currently it is focusing on the somewhere around Kubernetes world, but in future there can be many possibilities on the service mesh, because service mesh is really big thing, and it is complex also, and uh, really nice kind of a thing. So everyone should understand how it works, and so you can go on various cloud native projects around the service mesh, and you can give it a try. So yeah.
Wow, we heard a lot of new terms here. We'll discuss them one by one. Everyone, we have a lot of pinned tweets. There is also a pinned tweet about this Twitter space. If you have questions, feel free to comment under the tweet. We'll look at them and ask our guests about them. Okay, we have a request for a question, and we'll take a question before we go to further questions. Hi, Ankur. Can you please ask your question?
Thank you for giving me this opportunity. So my name is Ankur. I'm CTO in Field Service. So like we have launched our platform in 2018. So at that time we have like majority we used to work on AWS. So we learned the ACS fast, and right now like we have running 30 plus microservices. Just 1 minute. Sorry guys. So those 30 microservices are like communicating using the service discovery at this moment. So my question to you is like our system is live, and the things are quite some of the things are like decoupled, some are tightly coupled. So is it feasible at this stage that we move our existing infrastructure from service discovery to service mesh without disrupting our existing clients or existing solution? Is it feasible, or we have to like roll out new versions of each of those services to achieve it?
So this is a very deep technical question. And there are a number of ways you can achieve things like rolling out new versions of your app, right? You can even do this natively in Kubernetes if you really wanted to. But one of the challenges with doing Anchor, can you actually go on mute? I'm getting some feedback. Thank you. So one of the particular challenges within Kubernetes is actually being able to scale a rollout, and not only that, routing correctly to the right services. At the same time, implementing this level of ingress, because the ingress capability is basically how do I get into your environment and how do I get to the right resource. But that gets really, really convoluted as your app tends to grow, because guess what? It's not just about one or two services. We're talking about thousands. So when it comes to rolling out, right, there are particular configurations that you can apply for traffic management to basically identify your current version of a service and then a new version of a service. And you can go ahead and configure it in such a way that you route traffic, a certain percentage of traffic towards your original version, and a small subset, maybe 5 to 10% of your traffic towards that new version. In fact, you don't even have to make it available until you decide you want to, and that's a notion called dark launching. So you can launch it, make it there, present, but not actually accessible, or traffic is not going to route to this new service. But what it really comes down to is a service mesh can control how you go about routing to these different versions, and then ultimately, when you're doing, let's say, a production deployment, you're running this in production. You can guarantee that traffic will still continue to route to a service that will still give you a response that you're looking for. If that new version breaks, guess what? You still have a version to go to. So it implements a level of resiliency in the way you actually access that application. But resiliency is not just about that. There's so much more around the realms of how you set up things like retries, how you set up timeouts, so that you allow for services to respond to other services in time, so you yourself don't get a 404 not found or a resource that's not accessible.
Thank you. Just one more thing I would like in it. Like, let us suppose, since I told you, like, we are currently working on using the service discovery. When do you think the time will come we actually need with the service mesh? Or in another way, I would like to ask, what are the advantage of using the service mesh over service discovery?
Kat, you want to take that one?
Sure. So implementation is obviously a loaded question, in that if you have Kind or Kubernetes on Docker desktop or whatever locally, you can deploy a pet store app, deploy the most rudimentary configuration of a service mesh, restart your application pods, and everything in theory should continue running just as it did before, just now things are happening through the mesh. Then you're going to be adding policies a little bit at a time, whether that's activating MTLS or disallowing traffic between all pods by default, and then only allowing certain pods to talk to each other a little bit at a time with annotations on your services. All of these things are baby steps all along the road to adopting a service mesh. In a really simple environment like Kind or Docker Kubernetes or whatever you develop on, that's a fairly simple path to take in a weekend. If you're looking at a highly complex, multiple AZ, multiple global regions production with global DNS, the routing to the right region for the request, and all of these different things, the complexity of each baby step increases exponentially. So trying to answer, can I adopt? On a Twitter space is a little bit challenging, but those are some of the types of steps that you'll be taking regardless of your specific implementation. And then as far as should I adopt a service mesh, I actually have not practiced the service discovery piece myself. Watching people adopt service mesh and what their motivations are, though, can be illuminating, just because they start getting the discovery and the observability and things like the retries and things like that all in one package. The others may have more information on the actual service discovery versus service mesh people problems.
Yeah, so I think like previously it was like we have to write like networking workaround code around applications by doing things like retries, timeouts, circuit breaking, a lot of stuff. So the service mesh can save you like having to write networking code and directly into your application and provide you like default expectations of your resiliency for all the applications in your service mesh. So yeah, that aspect it can solve your issues. uh, I'm also can't guarantee on the service disk directory part, but yeah, that's what I wanted to mention, so you can look on that thing. Hope that helps.
Thank you, guys. It has been really helpful.
Yep, that was a great question. Folks, if you have other questions, there is a pinned tweet. You can comment or reply under it, and we'll get them answered. Um, Next, in the last conversation we heard the words Kuma and Istio. So, what are these tools? Are these tools how you implement service mesh, or are there other tools out there? Um, we would like to know. Would any of you like to answer?
Yeah, there's so many different kinds of service meshes out there. In fact, it all started with things around what Lyft, if you're familiar with Lyft, the rideshare company, was doing, even Netflix for that matter. They had all of these microservices, but they needed a way to implement, some of the key features of a service mesh without really knowing that they were deploying a service mesh. And that's how a service mesh, technology was born. What Lyft did was they actually took the Envoy. If I'm not mistaken, they even invented the Envoy proxy, or heavily contributed to that project. But they effectively took it, modified it, and made it mesh-like, because that's effectively what it is. Envoy is a data plane and even a control plane to an extent. But when you can write an engine that can push policy and instruction to a proxy and do this, for as many times as you need to, for however many objects that you have, then you're able to have mesh-like capabilities. But the reality is, that sparked a movement of all of these companies creating service mesh technologies. So the ones that you'll come across quite often are things like App Mesh from AWS. You'll come across Kong's Kuma Mesh. You'll come across Linkerd, the service mesh, and then you'll also come across several others. But I'm obviously going to plug the Istio service mesh because it has had a lot of work put into it. Now, when it comes to assessing which service mesh do I choose, there are a lot of factors that come into play here, right? And one of the things I highly recommend is doing an in-depth comparison of what you're truly after. There are trade-offs with every single service mesh. One might be very complex and may take a lot to get up and running, but it offers significant customization. So you could do a lot of fine-tuning, fine-grained access control and whatnot. There are other meshes out there that are very simple, limit your functionality, but provide you the necessary functions of a service mesh. But the trade-off is, because it's simple, you don't get to customize. So one of the things to consider is sit down and assess what's most important to you. Do you want complete control, which means that you're going to have to invest time and effort into really developing out a solution? If all you really want is a service mesh, then maybe something very simplistic is great to start off with. What you'll find, though, is that over time you may scale to a point where you need something that is highly customizable and tunable. One resource that I'll point out is I think it's servicemesh.es or something. I'll try and find a link, but it actually gives you a great comparison of all the different service mesh technologies that are out there. Here's the other thing too. There are certain service meshes that are built with a proprietary nature in mind. What that means is it's built for the environment it's supposed to run in. Let's take App Mesh, for example. It's actually probably called something different today after AWS made a whole bunch of announcements. But App Mesh only works in the AWS ecosystem, meaning this is great if you're using EKS, Fargate, if you're using ECS, even if you're using EC2, which is a virtual machine, right? So it's accommodating a variety of styles of workloads, but it's limited to just the AWS ecosystem. Now, if you're heavily invested in that ecosystem, sorry, I'm plugging AWS a little bit here because I'm at reInvent, but if you're invested in that ecosystem, then AppMesh might be for you. Now, if you're in other ecosystems, or if you're in the cloud native ecosystem where you're just picking your tools, you may not want to use a proprietary mesh. You may want to use an open source mesh. And that could either be Istio, Kuma, or even Linkerd for that matter.
Would you like to go ahead, Kat?
Yeah. So choosing products in the technology space is always a big chore. But just like Marino was saying, you have some that are extremely capable of customization with lots of tunables, bells, whistles, knobs, levers. And you can create an incredibly well-tuned piece of machinery for your deployment. Or you can look at it from a simpler perspective of, I really just want to deploy a Helm chart. I want it to just work and have same defaults. And one of the ways that I encourage looking at selection is seeing your talent pool, your existing employee base, and the cost of maintaining an employee base that can actually handle and operate and resuscitate, a service mesh in the case of a breaking glass scenario. So evaluate the level of complexity that you adopt based on the level of complexity that is healthy for your organization, as much as investigating how much power you actually want over your service mesh. And then another thing is you have to look, just like there are certain meshes that are very well integrated into, say, Amazon, if you want to, or AWS, if you want to be able to do multi-cloud or hybrid cloud where you have some in the cloud and some on-prem, or you're doing mixed types of compute, like you're trying to extend your mesh out beyond just Kubernetes. All of these things also come into play when trying to pick a product. And comparing those feature sets, again, there's some really good resources out there for looking at those different features. It's all a balance.
Cool. We are really glad that you also explained about the different types of service meshes out there, the different projects and companies, and also gave a good brief about how to pick one, which is really nice. We have a question from Pranav. Pranav, please ask your question.
Hello, am I audible?
Yes, you are.
Okay. Hey folks, I'm Pranav and I'm a student learning some stuff about DevOps. I've got a question that I got to know about. eBPF was one of the most talked about and discussed technology in recent KubeCon. How is that related to Service Mesh?
Marino, you can take that question.
Or Kat. Go ahead, Kat.
Yeah, Marino, I'm curious. Has it come up in reInvent a bunch? I didn't make it this year.
I'll be honest. There was no mention of eBPF at reInvent at all.
Wow. Okay.
Yeah, and I honestly feel like they hide a lot of the technologies that are underlying in some of their services, and it's because it's proprietary, right? Sometimes you don't get to see the under the hood code to really know what's going on behind the scenes. Now, going back to answer your question around, where the intersectionality of eBPF and service mesh is, let's think about the sidecar resource for a second, right? And what it's having to do. So the sidecar resource is actually rerouting traffic on behalf of that main application container. But there's suboptimality at times with the rerouting because we sometimes have to use tools like IP tables to be able to achieve this rerouting. And that may not be efficient at times. So there has been investigation into optimizing the sidecar using eBPF. And what that really translates to is doing kernel level packet processing to be able to route traffic efficiently and faster to consume obviously less CPU and memory overall. Now, where is this today? I really don't know. And I say that because I don't actually participate in the development cycles, but I do know that the Istio community is investigating using eBPF to optimize sidecars. Also, what is eBPF? I won't answer that, but I will add thoughts. Kat, do you want to answer what eBPF is?
Yeah, okay. So I'm going to take my best stab at it here. I'm a little unpracticed at this part of the conversation, but I have gone down the rabbit hole. So I actually like to talk about eBPF and WASM at the same time when we're talking about it in terms of service mesh or any proxy in general. Because what you have is some different technologies for doing accomplishing the same end result in the scope of a proxy. eBPF can do a lot of things, not just for proxying. WASM also is relevant to a whole lot of stuff. And one of the things it can do is give you a place to perform packet filters. So in the terms of service mesh, we want to look at it kind of like a mail sorting center. So in a mail sorting center 100 years ago, you would have a human, they would be reading a parcel and figuring out how to sort that to get it to its correct destination. And as time evolved, we invented machines, machine learning. They can see the patterns way faster than human eyes and route, thousands more packages. So now if we take a look at a proxy technology, you have to say, okay, what is my most effective tool for this particular packet filter? Should I be running it inside of Envoy itself? Should I drop that into an eBPF packet filter? Or should I use a WASM plugin to handle that packet filter? And the core technologies underneath just change where in the kernel or user space the packet filtering logic is occurring. And computer scientists can go off into absolutely crazy tangents explaining how that impacts the speed or the scalability and observability of different processes. But at that high level, it's really just trying to identify for a given function, where is the most efficient place to locate that function and which technology implements it in the most practical manner.
Please go ahead.
Thank you for the answers.
Yeah, so I'm audible.
Yeah, yes, Rohit.
Yeah. So about eBPF and how it is like related to the service mesh. So introducing the eBPF, it is some kind of a thing like if you know about the TCP dump. So previous it was known as a classic BBPF kind of thing. So extended part of it is the eBPF. So it is like if you have your event-based programs like attached to your hook points, like if you have some various events and when you trigger something inside that, so that event-based programs attached to some hook points. So that is your there is your kprop type of programs. So here when the function is called, that is comes under your BPPF program. So that is kind of known as a safe programs. So it why safe? It like directly can't crash the kernel, or it like guarantees your no infinite loop kind of a thing. So so in simple definition by the eBPF, it is just a technology, your Linux technology, which I guess enables users to run custom programs, which you call in the technical terms is a sandbox programs. So I think eBPF can be introduced in the service mesh somewhere where is the your observability. So if you have know about the observability, so inside your service mesh, so I guess in the future, so observability can be extended by using your eBPF. So how it can be done? So if you know your application is currently in the Istio data plane. Your application is connected to the Istio proxy, your Envoy proxy. So inside that, if you know about your network stack, so there is some sockets, right? So that sockets you can connect with the eBPF. So that eBPF can use the network policies using your auth 0 or your auth z or something, and then you can extend it for the what we say observability kind of thing. So yeah, I think it can solve various use cases for our network stack, and it can be useful for gathering the additional data in your uh, current service mesh, and it will help you to troubleshoot more often using that data, because you have now enough data for your technology, your service mesh, right? Another thing is like you can when you are scraping this matrix through the BPPF programs, you can add the custom matrix, and you can do like you can connect it to the standard Prometheus, or you are on any open source visualize observability tools you are using. So you can scrap it and you can put it inside that Prometheus. So I guess that's all your question.
Marino, you had your hand raised. Would you like to add something?
No, not at this time. Rohit and Kat did an excellent job.
Okay, cool. Uh, Before we move on to the next question, people, we have pinned tweets. Do follow them at Kubesimplify. We also have Cloud Native Stories, which is which is an initiative where we share stories from different founders, DevRels of different companies. Do check them out. Uh, the next question is Rohit, while he was speaking, he mentioned about something called ambient mesh. Personally, while I was looking at service mesh, I've come across this. Uh, can any of you explain what ambient mesh is and how it works? Yep, please go ahead, Marina.
All right. I will preface this with the fact that ambient mesh is still experimental. So anything I say right now can change. Literally next week, it could be something entirely different. And the reason why that is because there is still continual and ongoing development in the world of ambient mesh. What is ambient mesh? So a while back, Google and Solo started investigating a sidecarless model of Istio, where we remove the sidecar from the main application container, but we still preserve the functionality of service mesh. We just do this elsewhere. So what ended up happening was they broke up the sidecar into two components, a layer 4 proxy that handles layer 4 TCP routing and even MTLS. Two critical features to basically provide, some security and even traffic management. Now, this is perfect because in this model, I don't have to deploy a sidecar, but I can still take advantage of things like traffic routing. I can still take advantage of the MTLS and security. Um, the best part about it, though, is that I don't have to roll out sidecars. Now, there's an actual issue rolling out sidecars. If you already have an application deployed to production without a service mesh, and then you decide, I want to deploy a service mesh with sidecars, you actually have to re-roll out your deployments because there's something called sidecar injection that goes on to basically inject that Envoy proxy or that sidecar proxy. But wait, I have to restart the deployment, which means that original manifest that Kubernetes was looking at has now changed. Right now that it's changed, this means my apps go offline and then come back online, which is not something I always want to do. So this requires some level of planning around when I decide I want to have some downtime so I can roll this out. This is an operational challenge that ambient mesh offers because you can onboard a production application. Well, hold on, quote unquote production. You can onboard an application into a mesh without loading in sidecars, still preserving that sidecar-like functionality, except what ends up happening is multiple workloads leverage this layer 4 proxy to be able to do service mesh-like functionality. Now, what about layer 7? Where does that come in? So the sidecar has been broken up into a layer 4 proxy as well as a layer 7 proxy. Anytime I have to implement any sort of authorization at layer 7, so let's just say I have a service that needs to be authorized to perform HTTP GET operations on another service, that means I have to use a layer 7 proxy to intercept that and act on that policy and enforce it. So in this model, it still works, it's still functional. We still can deploy layer 7 policies. We're consuming less resources as well, which means I don't have to consume an additional set of CPU and memory for every application that I have. In addition to that, this means that I can consider less costs being, or just a lesser cost overall for operating a service mesh with Kubernetes. So there are some really great benefits to doing this model or approaching this model. But here's the other thing too, right? It's not an either or situation. It's an and situation. I say this because there are workloads that definitely will continue to need that sidecar. There are workloads that actually having a sidecar has disadvantages for them for how they operate. So it's an and situation, and in the future, when you deploy this into production, you may see both modes operating together. There's a lot of information. I think Rohit just put up a blog post on the Jumbotron there, so please go check that out.
Okay, I don't have as much in-depth to offer here, but I like to talk about this belonging in the R&D space of service mesh. I know that there were at least some submissions to KubeCon that included, eBPF will be the death of service mesh as we know it, or sidecarless mesh, and all of these different ideas. And they're really amazing ideas that people with bigger brains than I have are pursuing. But like Marino said, it's probably going to end up being a combination of architectures. So if you look at it from a financial perspective and what actually promotes value in a business, you have to consider compute cost. And if you're attaching a sidecar to every single instance of an application that you're running, in a small production, that's not a significant cost. You have a little bit of extra compute to massively improve your production efficiency, and it just becomes a no-brainer. You're not even really going to consider the AWS bill or the energy cost required to run it. However, if you are running massive productions and you're the one paying the AWS bill, or you're the one paying the power bill for your data center and buying those racks of hardware, the cost can actually amount to some significant, resources. And looking at things like ambient mesh and that whole sidecarless mesh thing, you, in theory, have the benefit of reducing the overhead required to operate your mesh, which translates to real world money. So those are some of the driving forces behind these decisions. But just like Marino said, there are some workloads that probably will never play nice with the ambient mesh type of a scenario for regulatory reasons, if nothing else. Because not every problem is solved with a technology solution. Some things are regulatory, or their company policy, or something outside of our control that plays into the decisions made around multi-tenant, distributed systems and how you design those things. So things to think about. I didn't really give a whole lot of answer, but that's some of the give and take that's happening in the space.
Yep. Thank you, Kat, for adding that. For folks who are listening, if you want to learn about Service Mesh, we have a pinned tweet from Rohit where he explains about Service Mesh. And at Kubesimplify, we have a Service Mesh workshop, and also uh, Solo has a Istio related courses, so which are hands-on Service Mesh related courses. So you can also check them out. Uh, yep, Rohit, do you want to add something?
Yeah, so if you want to know more on the ambient mesh side, you can directly hop on to the Istio's what we say Istio's blog post or Istio's videos on YouTube or somewhere. And you are if you know, like in India, I'm trying to promote Istio sidecarless service mesh talks everywhere. So if you are close nearby, you can join the talks. So I guess upcoming I will be speaking at the DevSecCon, which will be online, so you can all attend. So it is just like as Marino told, like Istio Service Mesh is introducing this experimental kind of new data plane attached to Istio, which is your sidecarless data plane, which is called as ambient mesh. So previously you had like your Anwar proxy attached to the various pods which you are running. So what happens, you are just it is not like it will be directly removed or something, your sidecar will not directly removed or something, but it is just a new plane is introducing where your sidecar is not there. And if it is not there, it is thing like you can solve the various issues, like your what happens, your control plane is sitting outside your data planes, right? So now what happens, when this ambient mesh was introduced, it is not like it is directly connected to Z tunnel. And what is Z tunnel and stuff, you can it is like hard to explain in just a Twitter space, but you can check the various talks and kind of a thing. So best thing is, as you know, like previously you had to restart your pods or your application whenever you are using the Istio service mesh. If you want to attach new application that time, or so it was only available to attach application at the start or at the end, and if you want to add in between, then you have to restart, or right. So now it is just like simple thing, you just have to label the new data plane, which is Istio ambient plane, and you can directly attach your applications. So that was one of the great use case solved. And another is like cost reduction was it is like normal thing, right? You don't have sidecar attached to various pods, right? So now it is just one proxy per your entire node, and it will do everything, traffic things and network things inside your node. So cost will be reduced for the sure. So yeah, these things and awareness things and complexity is reduced. So I think it is kind of a nice experimental path the Istio community has started. So yeah, I'm supporting it, and I'm trying to explore more on this side. So if you want to learn, you can see my videos or kind of talks on the same, or you can directly hop on to the Solo Academy. There is dedicated hands-on workshops are given on the same, and try to explore them. Thank you.
Yep, thank you for that, Rohit. With that, we'll conclude today's talk and Twitter space. Thank you everyone for joining. Do follow all of our guests and Kubesimplify, and we'll be bringing you more content. Thank you, Rohit. Thank you, Marino. Thank you, Kat, for joining.
It was a blast. Thanks all.